Okay, hello student. Today we are going to do another lab, which is basically of we will be introducing pandas and how do we use it to perform some analysis on tabular data and how we can use it to filter some data sets. So we'll start with the introduction. You can find the introduction of Python by looking at the API documentation or by typing pd.dataframe followed by a question mark. Just like any other library, you have to first import the pandas. So let's start, and let's start by constructing a very simple data frame, which would actually create a table with two rows, with two columns. So let's see how it looks like. So we have already created a table with two columns, a column A and column B, and each column has 4 entries, so there will be 4 rows. We can see how this data frame looks like by typing the name of the data frame, which is df. So you can see there are indices representing each row, which starts from 0, and column names as we have given, which are A and B. We can you can also try this info tool to have more information about this data frame. So this actually tells you that there are 2 rows with indices 0 and 1, 2 columns two columns. The column indices are 0 and 1, and the column names are A and B. Each column contains 4 values, and all of these are non-null values. So there are no null values, they are all non-null. So this column actually tells you the number of non-null values in each column. Then the data type of each column. So for example, the first column contains only integers, so the data type is int64, and the second column contains objects, which are actually string objects. So there are very important, very good tools in pandas. For example, we can use the head tool just like we used it in Unix, and the tail to print the first few rows or the last few rows of the data frame. For example, if we use df.head with 2 in parentheses, it would just print the first 2 rows. And if you use tail here, it would produce the last 2 rows, and so on. If you want to access a certain rows or number of rows inside a range, you can use the indices in parentheses. For example, if we use this command, it will print the first starting from the first row up till the 3rd row, not including the 3rd row. So the last part or the end part is not included, so it would so it's just actually printing the first 2 rows. There are many useful functions to summarize the contents of a data frame, specifically the numerical columns. For example, we can calculate mean, standard deviation, etc. for all the numeric columns by running described. So if you use df.describe, it would give you all the major summaries of the data frame. Okay, so this is enough introduction. So let's start how we can use the pandas to create data frames and to manipulate them. So we have a data set which consists of World Cup logs. You can download this here and save it in the same directory as your notebook. So we are going to read this file using pandas. So this is basically a load function for pandas. Remember to use Unicode escape here. So if there are any non-UTF-8 characters, they could be ASCII characters. So first we load the file, and then we try to read some contents from the file. So if we use head, it by default, without any number in the parentheses, it by default prints the first five rows. So you can see there is client ID, date, time, URL, response code, and size. There are 1, 2, 3, 4, 5, 6 columns with their names as we used inside defining the data frame. Okay, now the task here is to find out how many rows are there in this data frame, and then we want to know what are the URLs between at a certain row, for example. So let's try this. So for the number of rows, you can simply um, check the length of the data frame, which would give you the number of rows. So for our data frame is log underscore df. Let's run this. So you can see there are 200,000 rows. For the then we can see some rows, let's say the rows from 85 to 87, and we just want to know the URLs of those rows. So we can use log underscore df. We only want to use URLs, URL, and so it would just give us just the column of URL, and then we can see the rows from 85 till 88, because 88 would not be included, so it would give us the URLs of 85 rows 85 till 87. So you can see these are the three URLs that we needed. Okay, then we can use SQL-like operations using Pandas. For example, we can use the select operation of SQL to filter the data on rows. So for instance, if we want to filter the data, if we want to extract the data only where the date column is 1st May 1998, so we want to only see the records of 1st May 1998, so we can use that this condition here, and let's see. So as you can see, it would create a Boolean array with where the condition meets, it would give you a true value. If the condition does not meet, it would give us a false value. So we can then use this Boolean array to filter our data sets. So we can put this Boolean array here, and it would give us the values where the array is equal to true. So let's see, you can see all the values are the ones where the date is 1st May 1998. We can also do this by directly using, instead of creating a Boolean array and then putting it inside the brackets, we can write this condition directly inside the brackets. So, and it would also give us the same result. Okay, another thing that we could do with Pandas is to filter data by columns. So for example, if you want to just have the data of two columns, all rows but just two columns, URL and response code, we can put them inside parentheses, inside brackets here, and then check, and you can see we have a data frame with only URLs and the corresponding response codes. Okay, next we try to group the data based on a certain value of by a certain column. So for example, if you want to group the data if you want to convert the data set into some groups by dividing it to multiple groups where each group contains the same response code, or each group would have all the samples with a certain response code. So we want to group by response code. you can use any other column name here. So the output is not a data frame. As you can see, it's an object, and basically the object consists of multiple data frames where each part is a data frame. So for example, if we try this, you can see we have 7 groups. N groups gives us the number of groups, and the keys are actually the unique values of response code. So we have 7 unique keys, and each group has the same response code for all the entries. And if you want to find out, if you want to check a certain group, let's say with the key value of 200 or response code of 200, you can see it here. This, and in this data frame, all the samples have the same response code, which is equal to 200. We can also group the data frame by multiple columns. So each unique combinations would be used by of those several columns. For example, if you want to group by response code and date, so all combinations of unique dates and response code would be used. So as you can expect, there would be more groups. And so let's try this. And then you can use group.describe, which would print the summary statistics for numerical columns of each group. Group.size would print the number of elements in each group, and group.sum or group.mean or median would print the sum, mean, and median values for numerical columns in each group. So let's try one of them. Group.describe. So you can see we have the response code of a group, followed by the count, number of items in the group, the mean of that group, the standard deviation, the minimum value, the quartiles, and then the maximum, and so on. Okay. Next, if we want to use, we can plot data directly from a data frame by using the plot command. So let's create a data frame, a univariate data frame with 100 random numbers, and let's plot it. You can see there are random numbers, so which are plotted, and we can use hist to plot a histogram. So the same data frame, but now we have a histogram for that. Okay. Joins in Pandas, similar to SQL, we can use Pandas to join multiple tables or multiple data frame based on a certain column. So for example, if we have, let's take 2 data frames, students, which consist of 2 columns, student ID and student name, and then we have another data frame which create tabular data with which is called grades, and it has student ID, class ID, and grade. Okay, let's say we want to know all of Bob's grades, so we can merge these two based on the student ID, and then we can calculate and then we can see all of Bob's grade by actually say when student underscore grades where name is equal to B. Okay, let's see. let's see. Okay, so you can see now the Bob's grades in each class ID 1 and class ID 3. Okay, moving on. We can use let's try this. Use merge to join students grades with classes table below and find out what class LS got an A in. So okay, so we have some classes with certain classes IDs and their titles, and then okay, so let's find out the class where LS got in A. So you first create a data frame class grades by merging by using merge dd.merge classes and student grades on student ID, and then you want to know LS grades, all LS grades, which are basically class grades when student name is what's the student Alice with capital A. Okay, Alice, and we want to know the class in which Alice got in A, so we can try grades where Alice underscore grades, the grade column is equal to A, and then we just want to know the title of that course. So let's try this. Okay, not actually the student ID but the class ID. Okay, so you can see this is math. So if for a better print we can write this as dot values. Okay, so it says math. Okay, next we go to the restaurant data, so that would be covered in the next part. So that's enough for stay put for the next part.